Alright, hello. I was gonna stop complex numbers on 2 videos, but then I realized I'm very bad at it because completely fumbled the last video near the end. I know what's wrong now, but then Seeps changing it. It's basically because I looked at sine and I thought it was cosine. I didn't think I was wrong there, and I didn't get the answer. Okay, yeah. Continuing complex numbers. Complex numbers. I'm gonna continue off to sciences after this, because I hate spec at this point. Okay. Alright. I'm gonna start the third one. Okay. First, going back to the normal questions. Okay. Not really. They're still hard. Okay. Not as hard as the last question of the last video though. Okay. The first question says a regular hexagon LMNPQR has its center at origin O and its vertex L at the point z equals 4. Okay, so let's draw like a plane. So this is z equals 4, yeah. God. Oh my god. Okay. What is happening to my thing? Okay. Okay, let's see. O is here. I'm gonna have a regular regular hexagon. So basically, because L is 4, so this must be a 4, and this is L. This is L, M, which is gonna go clockwise, N, M, N, P, O, P, Q, R. Okay, center O, and yep, and then part A says to indicate in the diagram the region in the hexagon which the inequalities, the magnitude of z is bigger or equal to 2, and negative pi over 3 is smaller than or equal. Okay, argument of z is smaller or equal, is bigger or equal to negative pi over 3, and smaller than pi over 3. Okay, so basically it says bigger or equal to yeah, so basically that. Okay. Let's see, a regular hexagon, yeah? That just means all of these are like, what is it called? Not equal, the equilateral triangle. Okay, wait, no, it's not called that. You know what, it doesn't matter. Those triangles with all 3 sides the same. Same length, okay. Okay, so z is 2. Okay, so based on the actual diagram, we know that that's okay. Let's just use the property of a regular hexagon. Yeah, yeah. This is easy to do. The angles are easy to do because we know they're the triangles. That means each of these has 60 degrees and pi over 3 60 degrees. So basically, it's bigger than this, smaller than this. So it's in between here. So it's in between this angle here, and it says bigger than 2. So we'll say 2 is here. This is 4. So that means that if that's 2, that's 4. This length must be at 16 for 12. Okay, that's not right. Okay. Okay, so this is 2. Okay, wait, no. We know this is 4 on top, which means that half of it, because it's a regular hexagon, is in the center. This is 2. If that is 2, then right here to here must also be 2. Okay, that's a valid explanation. So that means if I draw from down here, this will be a right angle because that's 2 as well. Okay, yeah, whatever. Okay. Because it's right angle, then we can just say the area in the question is just this area. It's bigger than 2. Yep, it includes it because it's bigger or equal to. and then it's in between the angles. That's indeed correct, I think. And part B says to find in forms of z minus c equals a the equation of the circle through OMR. OMR. Okay. OMR. So it's around like, oh my god. It's around like that. It's a circle like that. We use our circle theorem properties, I guess. So basically, this must be 60 degrees. This must be 60 degrees. So this, okay. Let's do that. So L angle LOR equals pi on 3. Angle LOM equals pi on 3. Properties of regular hexagon. And so that means that RLM reflex equals 2 pi take pi pi on 3 take pi on 3, which equals to 5 pi on 3. And since ROM equals angle, okay, equals, okay, that's still pi on 3 plus pi on 3 equals 2 pi on 3. Wait, that's not right. Wait. That's 6. Wait, no, that's not right. It should be 4. Okay. Yeah, no. Okay. And then that means angle RLM reflex equals 2 times angle ROM, proving that L is center of circle. What was it? OMR. So this is angle at center double circumference. Okay, whatever. That means if L is the center, then the thing is not that hard anymore. So that means circle. So it will be Z take, well, L is just 4. And the radius is 4. 4. That's it for part B. Part C says to find the complex number corresponding to N and Q. Point N and Q. And because we were using angles the whole time, it'll just be extra difficult if we use like the rectangular form. So just use the cis form. That basically means that Q is just 4 cis. Well, we know that that's, if we draw a line here, we know that that's 60, which is pi on 3. Then that just must be pi take pi on 3, which means it is 4 cis 2 pi on 3 because it's in Q2. And then N must just equal to 4 cis. Well, this time it's in Q3, so it's pi plus, which equals to 4 cis, that's 4 pi on 3. Yep, and then for part D, it says the hexagon rotated clockwise about the origin by 45 degrees. Express the form r cis theta complex numbers corresponding to the new position of N and Q. Okay, so let's do Q first again. Okay, so let's just say pi on 45 equals to pi on 4. Yeah, and then so making it rotate clockwise like that way means that the angle became smaller. Yeah, because it's calculated from the actual positive x-axis. So that means Q will equal to 4 cis 2 pi on 3 take pi on 4, which equal to 4 cis 8 pi on 12 take 3 pi on 12, which equals to 4 cis 5, 5 pi on 12, and n will equal to 4 cis, because it's rotating the same way and the angle's the same, so it's just still subtracting. So then cis 4 pi on 3 take pi on 4, which equals to 16 pi over 12 take 3 pi on 12, which equals to 13 pi over 12. Oh, forgot to write forces. Forces 13 pi over 12. Yep, that is indeed all correct, I think. Okay, yeah, whatever. They are correct, because I'm intelligent. Yeah. And then moving on to the next question. Let's see. It says the roots of polynomial z squared plus 2z plus 4 is denoted by roots are alpha, and how do I draw that again? Okay, yeah, forgetting how to draw symbols. Okay, alpha and beta. Find alpha and beta in polar form. So let's find alpha and beta first. So z squared plus 2z plus 4 equals 0, then z equals to negative 2 plus or minus 4 take 16 over 2, which equals to negative 1 plus or minus, that's just square root 12. Square root 12 is 2 square root 3, so 2 and 2 cancel out, so square root 3i. So that means alpha equals negative 1 plus 3 over I, and beta equals to negative 1 take square root 3 over I. No, I mean I times I. And then that just equals to, well, then it'll be negative 1 squared plus negative square root 3 squared. It'll be cis tan inverse. It'll be square root 3 over, it'll be negative square root 3. And that just equals to, well, that is just 1, that is just 3, so it'll be 2 cis, let's do square root 3 is pi on 3, but it's negative on the x-axis, so it's in the second quadrant, so that's just 2 pi on 3. Yep, so I think that is, yep. And now for beta, well, we know it's still this. Cis, but instead of that is tan square root 3 negative 1, which equals to still 2 cis. Well, that means it's in the Q3, and it's still going to be 60 because still square root 3, so it's still pi on 3. But pi plus pi on 3, so that's just 4 pi on 3. Yes. It's gonna be negative. Okay, yeah, I guess that makes sense. It can also be negative, but we'll just we'll use the normal radians, because I think this one's more normal. I forgot to write A. And for part B of this question, it says, show that alpha cubed equals beta cubed. So basically prove alpha cubed equals beta cubed. And that is just because it was squaring, I mean, putting things to the power of things. So we're using the polar form, which makes it easier. So basically it's 2 cis 2 pi on 3 equals 2 cis 4 pi on 3. Okay. Let's do left hand side equals 2 cis 2 pi on 3, which equals to 8 cis 2 pi. 8 cis 2 pi, which is going 130 degrees. I mean 360, 130, where did I get 130 from? 360 degrees. And that's just equal to 8 cis, because we're going to get to this answer, we can just say it's 2 pi times 2, which is 4 pi. Because if you go one more rotation, it doesn't really do anything. And that is equal to, well, 2 cis 4 pi on 3 cubed, which equals to the right hand side, and we've proven it. Okay. And for part C of this question, it wants to find the quadratic polynomial for which the roots are alpha plus beta and alpha take beta. Okay, so basically we can just write alpha plus beta equals to, well, where's my alpha? My normal alpha is here. I want to use the rectangular form because polar form, when you're adding and subtracting, that's just weird. Okay, -1 plus, so it's -1 plus square root 3i plus, well, that's still -1, not negative square root 3i. That just equals -2. And alpha take beta equals -1 plus square root 3i plus I plus 1 plus square root 3i, which equals to, well, the ones cancel out, so it's 2 square root 3i. And now we want to find the quadratic polynomial which the roots are these two. So that means the polynomial must just equal to z plus, oh my god, z plus 2 z take 2 square root 3i. And that's just equal to z squared plus 2z, well, let's do the other, so the normal ones, 2 square root 3i z plus 2z take 4 square root 3i, and that just equals to z squared take, well, you can say plus 2 take 2 square root 3i z take 4 square root 3i, and that's a polynomial. And for the last part of this question, it says find the exact values of alpha, beta, but inverse. Okay, I think that's called, well, inverse the imaginary part, alpha. And then, so basically, that's just alpha, which is 1, -1, plus square root 3i, -1 take square root 3i, plus -1 take square root 3i, -1, oh wait, it's inverse, so you just make that different, plus square root 3i, but then there's no more plus because the imaginary part is negative. And that just equals to this thing squared. So we can just simplify like 1 take 2 square root 3i well, this I got squared, so it's -3 plus, well, that's 1 again, but you plus 2 square root 3i because it's negatives cancel out, and it's supposed to be plus, but you -3, and that just becomes 2 take 6, which equals to -4. But yeah. Oh well. I mean, or is there an easier way to do this? I guess you can take out one of the things, but you still have to do some calculations. So you can basically just say that beta is just alpha. So then you can go like, actually, no, you can't do that. This is still the best way, but you can say beta is just alpha and then you make the working out easy. But the answer is still -4, so yep. Oh well, I actually successfully finished all the questions. I'm impressed by my not really, because these are obviously a bit easier. Oh well, bye bye. Hopefully you learned something. I don't know. Bye bye.